Does smashing uranium-238 provide more energy than uranium-235 in fission because of the extra bonds that are there? That's a great question, and it's going to require a lot more nuclear physics to really address that. Now, to start off with, when you have uranium-238, both the neutrons and the protons are paired. They're all even numbers, and so they're all paired. With uranium-238, you have 92 protons and 146 neutrons. So with an even number, each nucleon can pair with another where their poles are anti-aligned, giving you some adhesion, some attraction, a bonding force that's there. But with uranium-235, you only have 143 neutrons. So one of those neutrons is not paired. It's not bound as tightly in the nucleus. Now that's just a small part of all that's going on. You've also got the strong nuclear force, which is always holding all nearest neighbor nucleons together, kind of like the van der Waals force in chemistry, how one atom can feel a van der Waals force only for its nearest neighbor. And strong nuclear force is kind of like that in that it only goes with its nearest neighbors, but it's incredibly strong, unlike a van der Waals force, which is considered very, very weak. And so you got that going on, but the long-range force of the Coulomb repulsion, so the protons are still all pushing all of the other protons apart, with the strong nucleus force providing that binding energy that holds it all together. And then on top of that, on the surface of the nucleus, you got surface tension. All the strong nuclear force going on within the nucleons are holding them together, but on the outside of the nucleus, there's nothing out there holding or bonding to the surface of that nucleus where those nucleons are, and it provides a surface tension. Just like a liquid drop has that surface tension. The water molecules are all attracted to each other, except for on the surface, there's nothing outside there pulling them out, and so you get a surface tension pulling everything in, and you have all of these interactions taking place at once. And so that extra bonding energy with uranium-238 prevents it from being fissile as it is with uranium-235. But if I split apart the uranium-238, I do have the potential to get more energy out by breaking those bonds, those extra bonds that are in the uranium-238. But I've got to put a lot more energy into it in order to overcome the fact that those are more tightly bound because everything's paired up. And so when it comes to fissile nuclides, those are the ones that will fission with a thermal neutron. The fissionable nuclei, like uranium-238, require a really high energy neutron to go in and whack it hard and bust it apart. And so you can fission uranium-238 and get energy out, but it generally is going to require a really fast neutron or fast proton or something like that. So thanks for the question.